I'm Mark McMillan. I'm the Director of Marketing for Finelite. Normally, our President and Chief Technology Officer comes to these, but he had a Board of Directors meeting and he says, Mark, there's one meeting I don't miss, and that's when I ask my bosses for money. So he couldn't make it here, so I'll try as a marketing guy to answer all the technical questions that may come out. Finelite, we work with the CEC to develop some really challenging research under task flow ambient and ICLS, integrated classroom lighting system, and I thought those were tough. Developing an ambient LED luminaire that meets the needs was something that caused a lot more hair to come out of the head than even the research projects. What I'm going to show you, and actually listening to all these presentations, and I'm sitting there thinking, I'm only showing you a light. I'm showing you a luminaire. After listening to all this, it kind of feels like lighting's now easy to me. But LED technology, when we were looking at it, we really had to take a look and do our research and wait instead of just reflexively coming out with a luminaire. Instead of high-power LEDs that were typical, we used mid-power LEDs. And these are LEDs that you're going to find in your television sets that some of you may own, and even a lot of electronic devices. The benefit we found by going to this mid-power LED was, one, from a heat standpoint, we're able to take the heat away from it a lot easier. We don't need large, no heat sinks on the back of this luminaire, because the heat is thermal management is being taken care of so easily and so effectively that we're getting life, an L90, 90% light output at 100,000 hours. So that's twice what you're seeing with the high wattage LEDs. From that, we also have low temperature on the driver. So the ambient temperature on the driver area is lower, so we're getting in excess of 100,000 hours. And the other side of it we'll talk about here in a bit, glare control. A lot of times, we look at luminaires, they're efficient, but if they're glary, we found in research, it's got to be both. You've got to have glare control so the users in that space also adopt it. And I'll talk about a couple installations here. The efficacy, we're starting to get there with the closer to the fluorescence. 90 lumens per watt in a 2x2, 93 lumens per watt in a 2x4. And another aspect, we want to make it accessible, just as accessible as a fluorescent luminaire from when you need to service the luminaire down the road at 100,000 hours. Looking at energy savings, we can look at it from a watts per watt standpoint on luminaires, but we typically, in the building environment, we want to look at a typical layout. This is just a typical 8x10 layout, comparing a fluorescent luminaire to the LED luminaire, and we're seeing a 40% energy savings. And this is a good layout with a fluorescent. So we're seeing 40% straight away with just moving to the LED. It's 35 watts in the 2x2. Couple that with the task flow ambient approach that we worked on with the CEC and CLTC and ICLS, you'll see even greater savings. The best product developments, folks, are big skeptics. All right? They don't trust any data until they see it 3 times. So we tested this in 3 different labs. We tested it at LSI in Arizona, we tested it at ITL Boulder, and then we borrowed the sphere at CLTC, and we said, can you test this for us again? And we got similar results as far as light output. It's been qualified with the DLC recently. All the LM79, all the LM80 data is available, as well as the DOE's lighting facts label. Doing the in situ tests, by using those mid-power LEDs, we find that we can dramatically decrease the heat that's going to the LEDs, and the heat and LEDs don't really pair very well. So we're getting at max 54 watts at the LED itself, and the ambient 25 watts. That allows us to get the light output, the life over that with the light output. The benefits of the luminaire, glare-free lighting, and I think with CLTC and us, when we did the research into office lighting, if you don't have a luminaire that people can sit underneath in an office for hours on end, you are going to fail with regards to energy efficiency. I went in recently to a government building whose name won't be said to protect the innocent, because one of them's in here, and the luminaires were glary. They had people walking around with visors. They had people with sunglasses. They had people complaining, 5 minutes, thanks, so badly that they were disabling luminaires and then bringing in their incandescent table lamps from home. So I can power this up afterwards. When we marry the mid-power LED, we spread those LEDs out further, and that allows us to have even illumination on that lens. Coupling it with a good lens quality, we get glare-free lighting, so people are going to live in that space for 8 to 10 hours a day. It's controllable. We don't do controls at Finelite, but we integrate with watt stopper controls and any others that we may need. Affordable, but we could use your help. It's a free plug, by the way. Tell Jerry Mix. And low life cycle costs. Taking the in-situ data, we give that data to the LED manufacturer, and they project it out. Typical with the LED ambient luminaires is about an L70 at 50,000 hours. They took weeks to come up with our data because they didn't know what to do with it because it was so low. So this is L90, so 90% initial light output at 100,000 hours. Looking at the driver life, system life, if you had great LED life, but your drivers, went dead after 50,000 hours, you're not having system life. We gave the information to the driver manufacturer, and they look at the ambient, and they say, okay, you're going to get in excess of 170,000 hours. And they also warned us it's only basically because of the ambient temperature that driver's sitting in that cavity. If it was 20 degrees higher, it's going to drop down to 50,000 hours. So with the ambient, using those mid-power LEDs, we're able to get that life in excess of 170,000 hours. So a total life, system life of 100,000 hours is easy. Looking at life cycle costs, these are simple charts. I'm a simple marketing guy, and I like to put them in that way. Looking at how typical high-quality fluorescent luminaires work, and we sell them. At 30,000, 35,000 hours, you're going to have to replace the lamps. So that's lamps plus labor. Again, at 60,000, maybe you have to replace the ballast. Look at the LED luminaires. For those of you who've actually seen some of these, some of them are serviceable and some of them are not. So at best case, they're serviceable. At 50,000 hours, you're at 70% light output. You're replacing the light engine. At worst case, you're replacing the entire luminaire. So then at another 50,000 hours, you're going to do that again. With 100,000 hour, again, simple charts showing that you're bypassing that entire step. And at 100,000 hours, then you can replace the luminaire, replace the driver and the light engine. The potential, thousands of units, hundreds of thousands of units. We're talking simple, the same form factor as traditional fluorescents. The primary barriers, one, educating the market. Going past some of the bad blood that's some of the previous LED products have generated, and incentives or the price difference between LED luminaires and the fluorescents. Because I can show them life cycle costs, but we all know what are they looking for. First cost. That always wins when we're looking at through our projects. So we need those incentives to bring that closer in parity with the fluorescents. Availability, the complete line, we just introduced this in September. So introduced it, 10-day shipping, and that's the Finelite motto. You're going to be able to ship any amount of product in any quantity, any sort of configuration in 10 days or less. We manufacture all these products here in California. We have vendors from Southern California up to Northern California, and we assemble them in Union City, California. And we have, even though we only started shipping in September, we've already got about 20 jobs in place. One of them is at Google. So thank God for Google. They've got money to spend. But the wide array of luminaires from 2x4, 2x2, 1x1, 1x2, 1x4, just same form factors as the fluorescents. Non-energy benefits, if the utilities wanted to rebate these products or bring them closer in line with the fluorescents, we'll double what is the normal warranty of 5 years that's out there to a 10-year warranty. We're saying it's 100,000 hours. Well, we're going to step up and say it's a 10-year warranty, turnkey, lighting engine, as well as a driver. No mercury or lead, glare-free illumination. The light engine and driver, as you can see here, it's just as simple as replacing fluorescents. Replace the drivers just like a ballast. You just replace the boards just like standard. It can handle demand response. We don't do the controls, but we can set it up to incorporate other folks' controls. And we're also working on a module that will take a signal and drop it down to 50%. And if that's not enough, we can factory set it. So I got my note back there. So easily controllable, summarize, task low ambient, ICLS works well with that, all in California jobs, all available right now.
Great.
Yes, sir.
So you were saying that you're using mid-power LEDs, and it's 90% at 100,000 hours.
Yes.
What is a high-power LED? What would that be comparable at 100,000 hours?
Looking at the competitive units who are using high powers, they'll put them on a heat sink to draw that heat away. The typical that is out there right now is L70, so 70% light output at 50,000 hours. And so, we're trying to change the terminology because, where did the L70 come from? I don't know, but 90% light output at that 100,000 hours. If there's none
So
here.
do you have to pack more LEDs on in your fixture?
Yeah, we're using
More chips?
like for the 2x2 form factor, you're using an 8x10 array. They're affordable because they're used in a lot of different products, from the TVs. And so the 8x10 array, we're putting more in there, and that allows us to have more even illumination, so you do meet the needs of the users in that space. But we still manage the cost.
So has the efficacy improved on these mid-power LEDs? So that's why it's become, because otherwise it wouldn't have, everybody would have been.
You put more LEDs that aren't efficacious in there, that's just not going to result in anything. They have improved, and that's what we took for a while to develop it.
There's a crossover point that it's now making sense to do that.
The manufacturer of the LEDs got an awakening as far as how U.S. manufacturers can be pretty tough on what they want as far as output from them. So they're learning from that.
Yeah, I would imagine the heat sink management, the heat management cost, adding all that material, aluminum, and all these other things that you need to do is pretty costly.
Yes, so that really does help by getting rid of that, reduce the cost. So it is more affordable, but still in alignment with fluorescent. If they're going to go to a luminaire and to the traditional, they're going to look for the first cost, and that fluorescent is still.
So a 90 efficacy, you're looking at comparable to fluorescent.
Yeah, fluorescence, up to the 100 lumens per watt, so it's comparable, not exact. Getting there. Sure. Have to go outside mic range. Oh, we had a question right over here. Catch me after? Okay.
Here, you're not out of range. You can walk with this guy.
So, obviously, it's not the typical viewing angle, but when you pair, so you're getting even illumination.
There you go.
So you're getting even illumination across this, and when we look at them, we take it and put it next to 2T8, 3T8 luminaires to make sure it's in pair, so it does look the same. And when you actually do it, you find this is even more even than the T8s.
Does that, you said you have a full line. Does that also include your form factor and color?
Color as far as
color temperature.
Yes. So the typical ones that we're seeing is 3,500 and 4,000 Kelvin, and we'll have those in there for the full line of fixtures.
Okay. Okay. Any other questions?
Thank you very much.
So as far as cost effectiveness of your product is under current comparable product in the market, the 2x2 truffer, or where how do you stack up, and what would be the savings what does that yield in terms of?
With
Can you give us
regards
just a
to
back of the envelope sort of comparison?
LED to LED or LED to fluorescence?
Fluorescent.
LED market pricing right now, with the 2x2 form factor, they're wide, but with this, you're probably looking at 225 on 2x2 form factor. Fluorescent, you're probably at 135, 125, you know.
So $100 incremental?
$100 would bring them in pair.
And as far as the energy,
The energy, as we showed there, you're saving, you know, 40% compared to that, to the fluorescent.
so in a typical office end use, what do you?
Definitely in the offices.
What is 40?
even in
What
the
is
school.
40% in terms of runtime and day, years or months payback?
Oh,
Simple payback.
that's an easy question. I wouldn't have that. I'm not that fast with math, but and we can pencil that out pretty relatively easy. Not right now.
All right. Any other questions? Sweet.
Thank you.
Thank you. Looks great. Appreciate it.